Hello ladies and gentlemen, we are working on question number 23 on your test 2 review for Math 1033. And I know sometimes, because I've taught math for a number of years, that when you're studying for a test and you're going across certain problems, it just feels like mathematics turns your entire world upside down. But we do not want that to happen, so I'm proud that you're watching these videos and I hope it's helping you prepare for your test. So let us turn the world back around the right way. All right, so let's go do this one. Come on with me over to my paper, walk with me, and there we go. Let's find the paper, and we found it. Here is question number 23. We have a linear system. The opposite of 4x plus 5y equals 12. And 8x minus 10y equals a negative 24. Now, this is pretty much set up to use the addition method. Notice that we don't have a single variable alone, otherwise we'd probably be using substitution. But when the columns are aligned like this for you, the addition method is a very good idea. And what we're going to try to do is we're going to try to eliminate one of the two variables, either the x's or the y's. Let's say I decided to eliminate the x's here. What we want to look for is a number that both of these will divide into pretty nicely. And actually, the truth is, in this problem, that would be an 8. All right? So what we're going to do is we're going to take this top equation. All right, let me change out pens here. There we go. We're going to take this top equation and we're going to multiply it by a positive 2. And the reason I chose that, if I multiply negative 4x by 2, it will make it a negative 8x. And then the 8x down here, since I'm not going to do anything to this bottom equation, really other than multiply it by 1, will cancel. Okay, so notice what happens when I take the top equation and multiply it by 2. Let me get a different color pen here for you to see what's happening. When I take the top equation and I multiply it by 2, it becomes the opposite of 8x plus 10y equals 24. That's the top equation, everything multiplied by 2. On the bottom equation, we multiplied by 1, which is just another way of saying leave it alone. Now remember that our goal was to eliminate the x's. Well, we certainly did. The x's are gone, but so are the y's. So this side becomes a 0 equals, and when I add this side together, it also becomes a 0. Now, the reason I know this is a special case, all right? When all the variables are gone, this is a special case. So the question you should be asking yourself is, when is 0 equal to 0? And the answer is always, or all the time. So if I turn that into a two-dimensional problem with a system, when does line 1 cross line 2? And if the answer is always, there's only one way two lines can always cross, and that would be if they're really the same line. So what we're dealing with here is a dependent system. Remember, dependent system, one line on top of the other. The solution set here can be written in a couple ways. One way to write the solution set is all points on the line. Okay? That's how to write it in English. All points on the line. Another way to write the solution set is using set builder notation. The answer is the set of all ordered pairs such that, okay, and then we could go to either one of the two original equations. Let's take the top one. Come back down here. Negative 4x plus 5y equals 12. So what this is telling me is the solution set all points on the line is the same as saying all ordered pairs that lie on this line. And remember, the reason that it didn't matter which equation you wrote is because they represent the same line. All right. Thank you.